Okay, hi guys. I'm just going to quickly do the relative growth rate for you and the root shoot ratio. I'm not really going to look at the actual aspects of the pracs because I've covered that in the pre-pracs of the actual pracs many times already. So I'm just going to do specifically looking at the results, looking at relative growth rates and root shoot ratio. So the first thing is that you've got to understand is that you have measured maize and pea, and you know that maize and pea have different growth forms. Maize is generally always going to be taller than pea, and pea is always going to be smaller and have more leaves than maize. Always. That's just their growth forms. You can do it. And like I said, you wouldn't compare me to an elephant. So we have to remember that you measured roots, shoots, number of leaves. You measured the initial and you measured the final. Okay. And you measured it for maize and you measured it for pea. So you cannot compare maize root length to pea root length. You cannot compare any of these parameters between the two species. The only thing that you can do and that you should do is please forgive my spelling, is compare root length, shoot length, number of leaves between ambient and elevated. But who gives a flying potato about the initial value? Who gives a flying potato? Nobody. Nobody. The most appropriate thing that you can do, the reason why you took an initial and a final value is so that you can get a change in the whether you opt to do percentage change in, which you should recognize from the potato prac, or if you just want to do change in roots between final and initial, change in shoots, that's fine. Essentially, what I'm saying is that you need to take the final and you need to minus the initial from it. Final minus initial. And this should give you change in, and if depending on whether you decide to do percentage or whatever, that's up to you. Not really appropriate in the scenario to do change in percentage, but definitely change in grams, change in number, change in centimeters, etc., length or whatever. If you have a graph, so now remember that for initial, for roots, you are going to have 5 points. Yeah, you're going to have under ambient, you're going to have initial for maize 1, maize 2, maize 3, maize 4, maize 5. Yes, great. You cannot put the initial and the final for, first of all, you should not be putting maize 1, 2, 3, 4, and 5 on your graph. You shouldn't be doing that. And you should not be having initial and final on the graph. You should no. So let's. I'm not going to give you the answers, but ultimately you've got 5 points. If your graph has got maize 1, 2, 3, 4, 5 as bar graphs on the x-axis, it's wrong. If you've got initial and final somewhere, anywhere, it's wrong. Wrong, 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 wrong. That is the raw data, and we don't want to see it. We want to see that you have analyzed and done some sort of statistics on the data. So you've got ambient, initial, and final. You're going to get a change. You're going to get a change, final minus initial here. Final minus initial. You're forgiving my spelling. Here. Okay? Put that up there. You're going to get a value here, 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 and here. You're then going to calculate the average of these and the standard deviation of these, and it will be this that you will ultimately put in your report. We do not need the initial and final values in the appendix. We don't even need the change in the appendix. All we need is this average and standard deviation. We're not going to look at your appendix unless it's relevant information, such as a photo or something like that. And then obviously you're going to do the exact same for elevated, and then lo and behold, you should get a value. So you should have 4 values for, let's say this was, you decided to do roots first. You should have 4 values, one for ambient, an elevated for maize, and one for ambient, elevated, ambient maize, elevated maize, ambient P, elevated P. So you should have 4 values for an individual parameter. You can, or you should not, put maize and P for these things, for these parameters on the same graph. Absolutely not. But you also need to think about it. There's nothing worse than getting a script from a student and they've got a graph for roots, maize, ambient. They've got a graph for roots, maize, elevated. And then they've got a graph for roots P and shoots P. And someone put number of leaves on the same graph as roots and shoots. We're going to have a problem if it's not the Z axis. You should not be chucking in graphs to bulk up. Think about it. Think, okay, roots, shoots, number of leaves for maize and P. 4 values for each point. What would this look more appropriate in? I know, a table. It is okay if you do graphs, but please don't bombard us with hundreds upon graphs. Be smart about it. And remember, you cannot compare at this point P and maize. They are separate. The only thing that you can do for these sections is compare the roots at ambient to the roots at elevated. There should be no comparing at initial and final. If you cannot tell that they increased, we've got problems. Then you did the experiment wrong. Ambient and elevated for roots, shoots, number of leaves. You can take it a step further, because what do you have? You have fresh weight and you have dry weight. You can represent it either as fresh weight and dry weight. You can add it to your table along with these concepts, or you could be very smart and measure relative water content. I'm not going to tell you how to do relative water content. If you want to, you can go look it up. Just saying that it is a very smart move to do. So this is comparing between ambient and elevated only within the species. Great, fantastic. But the point of this study was increasing atmospheric CO2 concentrations to maize and pea to see which one, the C3 or the C4, grew better. So, this is all great and fun and well. We can tell, at which one do they perform better under ambient or elevated. But how do we answer our research question, which is which photosynthetic pathway is going to do better under elevated CO2 conditions? In order to answer that, we have to be able to compare maize and pea. And the only way we can compare is if we do relative growth rate and the root shoot ratio. I'm going to do the root shoot ratio first because it's much easier. Now, you took a final dry weight and you also took centimeters. Now, some of you may have separated the roots and shoots. If you have, well done, smart cookies. This is the more correct way. Not saying you can't use centimeters, and if you only have centimeters, you've got no choice. You're not going to lose any marks because you are presenting the centimeters. You might lose marks in the overall impression. In that overall impression, you might lose a mark or two because it is much more impressive if you provide us with dry weight root shoot ratio instead of centimeter root shoot ratio. But it's not a problem, okay? So for a root shoot ratio, this is the only point or the only parameter that you do not have to have an average and a standard deviation. This is the only parameter whatever, that you don't need a standard dev. The only parameter. So what you've got now is your final dry weights of roots and shoots for your maize 1, 2, 3, 4, 5. You get the average of this, of the roots. You get the average of the shoots. You obviously take your, I wrote it in, I don't know why, it doesn't matter. You take your shoot divided by your root, or you take the bigger number divided by the smaller number. The bigger number divided by the smaller number. So the smaller number will always give you the 1, and then you'll get, so this is an average root shoot ratio of maize for final dry weight. And you've got to say all of this in the methods and material, by the way. You've got to, if you decide to do relative water content, you better explain how you calculated relative water content. You've got to explain that you took the data represented here is final minus initial divided by, if you're doing percentage change or whatever the case may be. You've got to explain it in the methods, okay? That's where you're not getting all your marks. So anyway, bigger number divided by the smaller number, we get a ratio of here is 1:1.5. So yeah, 1:1.5. So this is essentially saying that there is really not a lot of difference, but the shoots are growing 0.05 faster than the roots. And more of the carbon, because remember, dry weight is carbon, so you could only really do it with dry weight. You can't make this comparison with the final centimeters, is that more carbon is allocated to the shoots than the roots. 0.5 more carbon is allocated to the shoots. And this might not necessarily play a big role in ambient and elevated experiments, you still need to represent it, you still need to be able to explain it, and you still need to be able to discuss it appropriately. But this is going to play a very important role in the inorganic and organic, and the light and the dark, because what you should note, well, we'll get there when we get there, but you will see very clearly this shift in power. You've got enough nutrients, shift it to the roots, make the shift it to the shoots, make the carbon so that we could get better yield in the shoots. Don't have enough water, shift the carbon to the roots in order to look for water, etc., etc. You can do the same with final centimeters. You just cannot make a comment on carbon. This is just saying that here, same process. This is the average. This is the average. And this is, again, I did it the bigger divided by the smaller. So I've got 1:3.5. This means that the shoot was almost 4 times larger than the roots. You can say most of the resources were given to the shoots, but you can't specify carbon because you don't know. You don't know because you don't have dry weights. That's an imbalance in information. So for dry weights, you can refer to carbon. For root shoots of final centimeters, it would be more appropriate for you to say things like more resources were allocated to the shoots, and the shoots were almost 4 times bigger than the roots. So that's the root shoot ratio, very easy. Only parameter you won't need is standard deviation. Relative growth rate, this is where the drama comes in. This is the most important one. Now, this section here is what you will use from this experiment to the inorganic and organic, and to the light and dark prac. This is the information here. It will always be this. You just need to remember it. You need to come and watch this video in order to get it. Anyway, so you need to record this down and you need to use it, because this will always be W1 for maize, and this will always be W1 for pea. And this is how I got it. I measured 3 maize plants and 3 dry weights. I measured the fresh and the initial. This was just for references purposes only. And I got the average of the dry weight. So this is my initial dry weight. Remember that this is simply ln. It's a logarithm. This weight 2 is the dry weight that you measured, the final dry weights, logarithm my dry weights that I measured, which are these. So how do you calculate it and get a standard deviation? Well, I made this up. This is all fictitious values. This is fictitious values. This is not. This is your stuff. This is your stuff that you will need for this equation. The rest is all fictitious. I made it up, so don't take it because it's wrong. So I measured my final dry weights. Let's say that this was in elevated, and I've got maize 1, 2, 3, 4, 5, and all I did was my equation, which if you look up here, ln, which you can do thankfully on Excel. Ln, you just literally type in ln. There it is over there. Natural logarithm of a number, and W, let me go back here, W2 would be my D22, which will be this value, minus ln divided by this. Now, for T1 and T2, T1 will always be 0, always be 0. T2, for the love of me, I can't remember if you guys did it for 14 days or 21 days. You better check the dates on that, because this 14 will change. If you did it, if the experiment ran over 3 weeks, then it's obviously 21 days. And if the experiment ran over 2 weeks, it's 14 days. I can't remember. So you guys should have recorded it down. You should know. So please just bear that in mind. It might not necessarily be 14, but essentially this would be the number of days that the experiment ran for. So T2 will be the final number of days, and T1 will be the first day, which would be 0. So, you know, boo-hoo, it's 14. So simple. Lynn, my value that, or your value that you calculated dry weights, minus ln of my value over here for maize, or this value for P, divided by 14. And we do this for maize 1, 2, 3, 4, 5. You do this for maize ambient 1, 2, 3, 4, 5. You do this for P 1, 2, 3, 4, 5 ambient, P 1, 2, 3, 4, 5 elevated. You then get the average and the standard deviation, and this will be in a graph. Tables are not always, but most of the time, tables are delegated to being secondary information. And remember, all that information about number of leaves, root length, shoot length, that's secondary information. This experiment was to establish which photosynthetic pathway did better under ambient, or did better under elevated, under increased CO2 concentrations. And in order to do that, the best representation of this would be in a graph. So you should have a graph that has on the x-axis ambient and elevated, and on the y-axis relative growth rate. And you should have both P and maize on the same graph. Hopefully you know that this is a final value. It is discrete, it is not continuous. So hopefully that gives you a clue as to what graph you should be using, but this will ultimately tell you who did better in what. So you first look at the relative growth rates. Now, I'm not 100% sure what your specific results are. Every single year it's different, but the literature suggests that the C3 should do better, because the C3 should do better under elevated, and the C4 should do better under ambient. However, this is not always the case for each year of this, but there are reasons in the literature for this. You just need to find it. Yes, so remember, you're gonna have I don't think I said the root shoot ratio. You are now obviously just gonna have 4 values. You can choose whether you want to put it in a table. It can't fit on a graph. I don't even know. I wouldn't know how to put it on a graph. You could either put it in a table, or you could put it in the results section in the wording of it, where you're explaining your results. That's fine as well. Your decision whether you do graphs or not. Can't change your mind. Told you my opinion. This is the important thing, and it needs to be the one that you spend most of the time on explaining. And this needs to be the one that you use to initiate ideas and these will support those notions or those ideas that you've raised in the discussion. So if you're saying something like C3 does better under ambient and elevated, then C relative growth rate and supported by leaf da 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 da. That's how you should be thinking. This is supplementary, this is the main. Every single year, without a shadow of a doubt, someone gets pretty much most of the students get the units wrong. It's grams per gram per day. I don't know why students tend to leave that out. Leave it out, you're going to get minus marks because it is a unit and there is points for appropriate units. I think that's it really. You should by now have an understanding of what the research question was, what is expected of you. Please concentrate on those methods and materials. Explain how you got relative growth rate, and for goodness gracious sake, reference it. You mean great? You can now. This is where an appendix is very smart. Putting this equation in the appendix and saying relative growth rate was calculated using the relative growth rate equation as per see Appendix A. That's why you have an appendix. So reference it. Important. I don't even mind if you reference a textbook for this one. You should use a research paper. It's everywhere, but it's okay if you reference a textbook for the relative growth rate. That's fine as well. Yeah, I think that's it. You don't need to do actual SPSS, the t-tests, etc. You don't have to do that. Your stats comes from you explaining that you calculated the averages and the standard deviations, and you did a change in fresh weight or the change in root length over 14 days or over 21 days, etc., etc. Good luck, I guess. Don't email me on the weekend before it's due. I don't look at my phones for emails from varsity, and I only get it on Monday morning, and then it's too late, she cried. So Friday is really your last day to ask questions. Also think about it. I'm not sure when you have a TAT. If we need to organize a tutorial where I take the Zoom lesson for a day or something, we can organize that with Dr. Nati, if you so desire or wish. Okay, this is due on Monday the 4th. On Monday the 4th, we are putting out the light and dark experiment, and you are taking the dry weights of your organic and inorganic. Okay, stay safe. Bye.